Today we're going to look at two sections. We're going to look at section 5.4 and 5.5. So today we are going to recognize polygons, understand how polygons are named, and recognize diagonals, as well as then finding missing values for parallelograms. So a polygon is going to be a plane figure. So it's essentially, if I'm looking at these pictures right here, hopefully we notice that there's some kind of pattern with what I'm giving you an example is a polygon versus what I am giving you an example that is not a polygon. So if I look at the four pictures up here at the front, notice that every single one of those pictures, they are all connected. Every single side connects to another side. Notice that the first example that says non-example isn't connected. The P and the N don't connect. It is an open figure like that, and so that would not be a polygon. Everything else with the first four examples, they all are dealing with segments. Okay, segments are not curved. If we look at the second non-example, to go from H to G, there's a little curve to it. So no curves are involved when we're talking about a polygon. All right, so how do we name polygons? We name polygons by starting at any vertex and then proceeding to go either clockwise or counterclockwise with all of the letters. So if we look at this picture down here, and if we start at the letter A, we could either call this polygon A, B, C, D, E, F if we were to go counterclockwise, or we could say A, F, E, D, C, B when we went clockwise. So lots of different ways to name this because like it said, you can start at any vertex. So it says start at B and name the polygon in two different ways. So hopefully if you started with the letter B, you could go in a counterclockwise position. So that would mean B, C, D, E, F, A. Or if we were then to start at B and go clockwise, it would be B, A, F, E, D, C. Okay, once again, you could have started at F, at E, at D, at C. There's a lot of different angles that you could start this name at. Okay, vocabulary. One of them is a diagonal. It's going to be very, very important to know what a diagonal is. So the definition is any segment that connects two non-consecutive vertices. Anytime it's talking about non-consecutive, it means not right next to it. Like the numbers 2 and 3 are consecutive because they're right next to each other, but 2 and 4 are non-consecutive because they're not right next to each other. So vertices means angles. So I can pick an angle, and then I just need to make sure that I don't have the angle right next to it, create a segment, because then that would technically be a side of the figure, not a diagonal. So if I look at these two pictures, it says how many diagonals do each of these polygons have? We're going to write them with a dashed line. So say I started with this vertex right here. Well, there are 4 different angles in this picture. Once again, to draw a diagonal means that it needs to connect a non-consecutive vertex. Well, I can't go to the right because that angle's right next to it. I can't go below because that angle's right next to it. So the only vertex that is not consecutive would be this over here. So me drawing a dashed line, there's one diagonal. That's not the only diagonal, okay? If I go to this angle over here, same idea. The only diagonal that can be drawn goes to the vertex directly opposite it, okay? If I move down to then this angle, I could only draw to the vertex up at the top left that I've already drawn, and then same thing here. I could only draw to the top right, so those are already drawn. So it looks like in this particular picture, there are 2 diagonals. When I look at the next picture, let's say we start at the top angle here. Well, the diagonals that I can draw, here is an angle that is not next to it. And then I actually have another angle that's not next to it as well. But the other 2 angles in this picture are right next to it, so those are consecutive, so I can't draw in a diagonal. So if I move to then this vertex, how many non-consecutive angles are there? Well, there are 2 of them. And then if I move to this bottom angle down here, one of the diagonals is already drawn, but notice that I can draw in another one. If I go then to this angle down here, the 2 different diagonals that I could possibly draw are already drawn. And same thing here. If I go to this angle, the 2 diagonals that I could have possibly drawn are already there. So if I look, there are actually 1, 2, 3, 4, 5 diagonals, okay? Because you don't want to repeat when you're counting diagonals. So there are 5 different diagonals in this particular figure. All right, so now let's talk about quadrilaterals. A quadrilateral is a 4-sided polygon. There are actually quite a few 4-sided polygons, so the one that we're going to be focusing on today is a parallelogram. A parallelogram is a quadrilateral in which both pairs of opposite sides are parallel. That's why it was so important to understand parallel lines and the different characteristics of them, because now the idea of parallel lines are going to be in different figures. So specifically in this one, it's in a parallelogram. So we're going to start talking about properties of a parallelogram. And we can always use a symbol to represent parallelogram instead of writing out that word. So anytime you are doing like an algebra problem, if you want to shorthand it, just use that little symbol. So it's 4 sides. And notice that there's a little slant to it. But here are my properties. There are 5 of them. The first one is that opposite sides are parallel. And hopefully that makes sense because that's essentially what the definition of a parallelogram is. So opposite sides are parallel. So let's talk about then looking at this figure. So if I start at A, I can call this parallelogram ABDC. Or if I start at A, I could call it ACDB. Okay, I just randomly picked A to start it, but you can name it any way you want, no matter what vertex you start at. Okay, but if I'm talking about opposite sides that are parallel, well, in this particular figure, notice that one of the sides is AB, and the side opposite it would be CD. Those two, based off of our first property, those would have to be parallel. They're never going to intersect. So I would say that the side AB is parallel to the side CD. But there are 4 sides in this figure. So notice that the side AC is never going to touch the side of BD. So there's another pair of opposite sides that are parallel. So the side AC is parallel to the side BD. Okay, we've run out of sides, so I can't say anything else is parallel. But based off of that figure, here are the 2 sets of sides that are parallel. So that's my first property. Here's my second property. Opposite sides are congruent. So once again, we just talked about the fact that AC and BD are opposite sides because our first property told us that they're parallel. We also had a pair of opposite sides, AB and CD. Well, this is telling us that both of those sets of opposite sides are congruent. So I know that AB is congruent to CD, and I know that AC is congruent to BD. So opposite sides are both parallel as well as congruent. Here is my third property. Opposite angles are congruent. So we're talking about angles of that big parallelogram. So when I'm talking about angles, in this case, I'm going to have to use 3 letters. I can't just say angle A because there are more than one angle A. Same thing here. The opposite angle is the angle that's not right next to it. So these 2 angles, which I'd have to name with 3 letters, are going to be congruent because they are opposite. So I would say angle CAB is congruent to the angle of BDC. But that's not the only pair of opposite angles. Notice that this angle over here and this angle over here, those are opposites. They're not right next to each other. They're directly across from each other. So those are going to be congruent as well. So using 3 letters, because there's more than one angle B and one angle C, I can say that angle ABD is congruent to the angle of DCA. Those are my only opposite angles in this picture, so there's only 2 sets of opposite angles that are congruent. Moving on to my 4th property, consecutive angles are supplementary. So remember, opposite angles are congruent. I know that these 2 angles were congruent. I know that these 2 angles are congruent. Well, consecutive, like we just mentioned when we were talking about diagonals, consecutive means right next to each other. So that means I can take my angle, I don't want to call it angle A, but angle CAB, that yellow angle that I have highlighted, and there's technically 2 different angles that are right next to it. Both of those angles would then be supplementary to angle CAB. So I could say angle CAB is supplementary to angle ABD. So I have a yellow angle and a green angle, they're supplementary. But angle CAB is also supplementary, which means adds up to 180, to the angle of ACD. Okay, so then I can also say that the other yellow angle that I have, this angle BDC, that's going to be supplementary to 2 different angles because there's 2 different angles that are right next to it. So I can say that the angle of BDC is supplementary to the angle of ABD, as well as angle BDC is supplementary to the angle of ACD. Essentially, naming those 4 different sets of supplementary angles has covered them all. Because notice that angle ABD I have listed right here as well as right here because there are 2 angles supplementary to it. I've already got those listed. If I was looking at the angle of ACD, I already named those twice as well because there are 2 angles supplementary to it. So I have listed all the different sets of consecutive angles that are supplementary to each other in this picture. Like I mentioned, there are 5 properties, so the last property is based off of diagonals. Diagonals bisect each other. So hopefully we are okay with understanding that in this picture, AD is a diagonal and so is BC. So these are diagonals because they're inside the figure and it starts at an angle and it goes to another angle that is not right next to it. But if they're bisecting each other, that means that they are dividing each other into 2 congruent pieces. So if AD is a diagonal, notice that the other diagonal is touching it at point E. That means that segment AE has to be congruent to the segment ED. Okay, those 2 small segments that I have highlighted in yellow have to be congruent because it's being bisected. But since the diagonals bisect each other, that means that the diagonal that I have in green is being bisected by the diagonal I have in yellow. And notice how, once again, it's intersecting at E. So that means that the diagonal of BC gets broken up into BE, being congruent to EC. All right, so those are my 5 properties. Let's go ahead and now apply those 5 properties to some algebra problems. So we're only dealing with parallelograms. We've got 5 properties. In this first problem, they're wanting us to find x. Okay, so notice that we have this parallelogram RQPS, and I see that what we have marked in the picture are some angles. Notice that angle R is being represented as 12x plus 3. Angle S is being represented as 45. Notice that angle R and angle S are right next to each other. They are consecutive. So if we think about our 5 properties, 2 of them related to angles. Opposite angles are congruent and consecutive angles are supplementary. So because angle R and angle S are consecutive, so angle R and angle S are consecutive because they're right next to each other. That tells us that we have supplementary angles. So I'm going to take 12x plus 3, I'm going to add 45 onto it, and that has to equal 180 degrees. Let me kind of really quick explain to you why these are supplementary, because notice that these two sides are parallel because of our property that opposite sides are parallel. Technically, if I was to expand that side of RS, I have two angles that are interior, they're same side. Remember, same side interior angles when you're given parallel lines are supplementary. So that's where this is coming from. So now let's go ahead and combine like terms. So I'm going to add the 3 and the 45 together to give me 48. I'm going to subtract 48 from both sides. So 180 minus 48 is going to give me 132. I'll divide both sides by 12, and that gives me my value of x to be 11. And that's all this problem was asking for, so we're done. All right, here's another parallelogram, x, y, z, w. We want to find the length of xy. So notice that this time they are giving us two sides. Well, when we're talking about sides, we have two different properties. Opposite sides are parallel and opposite sides are congruent. Hopefully we recognize that parallel lines, while beneficial to us in some aspect, is not going to help us solve for x in these expressions. Okay, I want to use that second property that opposite sides are congruent. So that means I get to set 2x plus 1 equal to x plus 8, and I can start solving for x. So I'm going to subtract x from both sides. That will give me x plus 1 to equal 8. I'll subtract 1 from both sides to get x to be 7. But now solving for x wasn't my answer. We want to find the length of xy. Well, they're giving us the expression. It's 2 times 7 plus 1. 2 times 7 is 14. Add 1. We get a length of 15. All right, if we look at this information, I'm going to mark stuff up in my picture. So we're given that CQ is 3x plus 8. We're given that CA is 9x plus 1. And they want us to find the length of CA. Well, hopefully we notice that what they're giving us is one diagonal and then a portion of the diagonal. But hopefully we notice that because we're dealing with this diagonal, our only property is that the diagonals bisect each other. So that means that in this picture, the diagonal of BD is bisecting the diagonal of CA. Well, bisecting means that I'm going to divide it into two equal pieces. So if CQ is 3x plus 8, so is QA. And I needed that information because if they're giving me the length of the entire diagonal as 9x plus 1, I'm going to have to add the two small little congruent pieces because together they form the entire diagonal. So 3x plus 8 plus 3x plus 8, those two little congruent pieces are going to add up to the entire diagonal of 9x plus 1. So now I'm going to start solving for x first. I'm going to combine like terms on the left. Well, that turns into 6x plus 16. Still equals 9x plus 1. I'm going to subtract 6x from both sides. That gives me 16 to equal 3x plus 1. I'm going to subtract 1 from both sides. That gives me 15 to equal 3x. And then I'll divide both sides by 3 to find out that x is 5. That's not my final answer. They're asking for us to find the length of CA. Well, CA is given to us as 9x plus 1. So 9 times 5 plus 1 is going to give me my answer. 9 times 5 is 45. Add 1, you get a length of 46. All right, they're asking for us to find x. Notice that in this parallelogram, we are given some angles. We're given angle E and we're given angle G. Notice that these are opposite angles. And so when we have opposite angles, because these are angles that are not next to each other, but directly across from each other, opposite angles, when we're talking about a parallelogram, those are going to be congruent. So all I have to do is take 81 and set it equal to 7x minus 3, and that's how we're going to find x. So I'm going to add 3 to both sides to give me 84, now equaling 7x. I'm going to then divide both sides by 7, and we get x to be a length of 12, and that's all I need. So that is my answer. All right, if you take a look at this figure, I'm going to mark it up. We're told that CF is x minus 3. I'm told that FE is 2x minus 12, and they want us to find CF. Well, notice that the two different pieces that they gave us are pieces that are within this diagonal of CE. And remember, when we're talking about a parallelogram, diagonals bisect each other. So that means that in this particular picture, the segment BD, which is a diagonal, is bisecting CE, which means that CF has to be congruent to EF. And congruent means equals. So I get to take that x minus 3 and set it equal to 2x minus 12. I'm going to subtract x from both sides. Negative 3 then equals x minus 12. We'll add 12. So I get x equal 9. Now that's not my final answer because they're asking for the length of CF. Well, CF is given to us. That is x minus 3. 9 minus 3 gives us a length of 6. Okay, so that's us recognizing polygons, and we also now have these properties of a parallelogram.